All right, today we're going to talk about radicals and rational exponents. All right, so the definition of the principal square root. If a is a non-negative, it's got to be non-negative, real number. The non-negative number b, such that b squared equals a, denoted by b equals the square root of a, is the principal square root of a. Excuse me. The symbol, what you guys have called a square root your whole life, is actually called a radical sign. That's not called a square root symbol. That's called a radical sign because you can have square roots, you can have cube roots, you can have fourth roots, you can have fifth roots. And when there's no number in there written right here, like the 3, the 4, the 5, then we know it's a 2. Okay, so that's the most common one, obviously, is the square root, but it's not called a square root symbol. It's actually called a radical sign. The number underneath, if that was like, say, a 5, that would be called, the 5 would be the radicand. Okay, and together we refer to the radical sign and its radicand as the radical expression. So you call these radicals, not square roots anymore. Okay, that's your radical sign. Your radicand is a, and the whole thing is called your radical expression. All right, so the square root of 25 is 5 because 5 times itself is 25, and 5 is positive. The square root of 100 is 10 because 10 squared equals 100, and 10 is positive. You can put a negative on the outside if I have, and basically you're doing order of operations. The first thing you do in PEMDAS is look for parentheses, no, exponents, yes. Radicals live in the exponent world. They're part of the exponent. So I do that first, which is 5. Then I multiply by that negative, which gives me a negative 5. Okay? And same with this negative square root of 100 is negative 10 because the square negative 10 squared is 100 and negative 10 is negative. A perfect square is like we've been looking at. The square root of 25 is 5. It's perfect because it comes out to a whole number. The square root of 16 is perfect. It's 4. The square root of 121 is perfect. It's 11. The square root of 8 is not perfect. It's 2 point something, 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 something. And it goes on forever and ever and ever and ever, and it never ends. So this is not a perfect square. The square root of a negative number isn't real. So like if I give you the square root of negative 25, right now, as far as you guys are concerned, that does not exist. You can't take, if this is even, you cannot, a negative inside doesn't exist. If that's a 2 or a 4 or a 6 or an 8 or any other even index, all right, you can't do that. If it's odd, it's okay, but not if it's even. All right, so simplifying the square root of a squared. If this is even and this is even, when you in other words, they cancel each other out, your answer just isn't a, it's actually the absolute value of a. Okay, because technically, like when you do the square root of 9, your answer is plus or minus 3. But if you're doing, again, if these are squared, then you would have, like if I had the square root of w squared, those cancel out, but my answer is going to be the absolute value of w. Now, if I do like the cube root of w cubed, my answer is still w, but I don't need absolute value bars. Only if this is even. And they cancel out. Okay? So I do the square root of 4 squared. You can look at it a couple ways. You can say, well, 4 squared is 16, so the square root of 16 is 4. Or you can just look at it as when you take the square root of a square, they cancel each other out. And so your answer is what's underneath. All right? The square root of a negative 4 squared, again, this is what they're talking about here. If I look at it like this, square root negative 4 squared, these match and they cancel, so my answer is going to be the absolute value of negative 4, which is 4. And the square root of 6 squared, again, because those are even, it's going to be the absolute value of 6. Same here, it's going to be the absolute value of negative 6. So if we look at these, right now they're giving us basically perfect squares, so you should know these in your head. If you don't and you try and type them in the calculator, you're going to get decimals, which isn't necessarily wrong, but it's not what they're going to want, okay? The square root of 64 is 8. because 8 times itself is 64. Here you do the radical first. Square root of 49 is 7, times the negative is negative 7. When you take the square root of a fraction, you can take the square root of the top and the square root of the bottom separate. So on top, the square root of 1 would be 1. On bottom, the square root of 4 would be 2. So my answer would be 1/2. All right, when you're doing something like this, again, your order of operations, I have to do the exponent, I have to do this radical, but you've got this radical kind of acts like parentheses too, so I have to do what's inside first. And 9 plus 16 is 25, and the square root of 25 is 5. This is not the same as this, by the way. You can't split them, not addition. You can multiplication, but not addition. Look at the difference I'm going to get. If I split them and do this, you got to do the exponent first, and then the adding last. So the square root of 9 is 3, the square root of 16 is 4, then I can add and I get 7. Notice that I do not get the same answer. And for f, if that's even and there's a negative underneath, you can say it doesn't exist, or you can say that it is not real, which we'll learn about later how to write that. Alright, so you do this one, hit pause, come back when you're ready. And hopefully you got negative 11. The radical first is 11 times the negative is negative 11. Do this one, hit pause, come back when you're ready. And hopefully you got not real. If this is even and there's a negative underneath, that is not a real number. Okay, do this one, hit pause, come back when you're ready. And hopefully you got 3. Again, these cancel out, which will give me the absolute value of negative 3, which is just 3. Try this one, hit pause, come back when you're ready. And hopefully you got 8. You got to do what's underneath first. 100 minus 36 is 64, and the square root of 64 is 8. Okay, do this one, hit pause, come back when you're ready. And hopefully you got 17. You can't add them first, you got to do them separate. So I got to do this radical, which is 12, this radical, which is 5, then I can add and I get 17. Alright, so use a diagram to show the parts of a radical expression. Your index goes here. Your radicand goes here, and that's the radical expression. How do you simplify a radical expression? Well, I'll get to that one in a second. Okay, so the product rule for square roots. It says if a and b represent non-negative real numbers, then the square root of ab equals the square root of a times the square root of b, and vice versa. If they've split them up, you can put them back together. So if I had the square root, what they're getting at is, let's say that I had the square root of 50, okay? I can rewrite that as the square root of 25 times the square root of 2. That then is going to be 5 square roots of 2. Likewise, if I give you something like the square root of 25 times 2, or let's say 25 times 4, you could split it or you could multiply it first and then simplify it, and I'd get 10. Alright? The other thing, so in this example, I've got the square root of 25 times the square root of 4. You could, again, you could split it and you could do that's 5, that's 2, 5 times 2 is 10. Or you could say 25 times 4 is 100, which the square root of 100 is 10. Wow, I didn't realize I picked that same example. Alright? Which means that the square root of 25 times the square root of 4 is equal to the square root of 25 times 4. You can split up multiplication, but not addition. Alright. Now, what if, for example, I have the square root of, let's say, these numbers, okay, and I can't think of a product. You have a couple of choices here. And it just depends on how familiar you are with perfect squares. What you're looking for is you're trying to see if there's any perfect squares in the number. I mean, the square root of 32, if you type that in a calculator, that's going to give you a decimal answer, which isn't wrong, but they are going to want you to put this in simplest radical form and not give the decimal equivalent. So what you do is, one thing you can do, especially if you're not very good with your squares yet, and you will be, you'll get better at them the more we do this, but especially in the beginning, if you're not very good with your perfect squares, it's very easy if you will prime factor your radicand and only divide by prime numbers, 2s, 3s, 5s. Do not divide by 4. Do not divide by 6. Don't divide by 8 or 9 or 10. Those are not prime numbers. You can do it. It's not illegal. But for this technique I'm going to show you, you don't want anything except for primes. So only divide by those numbers. And if you can't divide by any of these, then the number is probably prime itself and you can't simplify it. Okay, so here's what you do. I could look at that and go, well, I know that there's a perfect 4 in there, so I could say that's the square root of 4 times the square root of 8, which would give me 2 square roots of 8. That's one way you can do it if you're good at recognizing your perfect squares. The problem is this isn't as simple as it can get because 8 has another 4 in it. So you see how confusing it can be? So then you go, well, crap, that's not done. So I could rewrite 8 as 4 times 2. So now I have 2 times the square root of 2, which is 4 square roots of 2. And you can see how tedious this gets when you think you've got it, and then there's another one in there, and you got to think. So I don't do any of that. This way might be a little bit longer, but I don't have to think as much. If I just prime factor my 32, which means I only divide by primes. If it ends in an even, start with 2 and keep going with 2 until you can't go with 2 anymore. 2 goes into 32 16 times. By 2 again goes 8. 2 into 8 goes 4. 2 into 4 goes 2. Now, because this number is a 2, if you get 2 copies of the same thing, in other words, look at this. So I could rewrite 32 as the square root of 2 times 2 times 2 times 2 times 2, which now you're looking for perfect squares. Well, if you bundle them, that would be the square root of 2 squared times 2 squared times 2. That would be the square root of 2 squared times the square root of 2 squared times 2. That's going to be 2 times 2 times the square root of 2, because that one isn't perfect, which would give you 4 square roots of 2. Now, again, writing all this out can be just as tedious. So you'll get used to it and you'll get faster at it, and then pretty soon what you'll do is you'll go, all right, if I'm doing square roots, I'm looking for bundles of 2. That 2 times 2 right here is 4. The square root of 4 is 2. This 4, square root of 4, is 2. This guy doesn't have a pair, so he has to stay under the radical. Only perfect squares get out. So then what you do is you take all your outies, which is the 2 times the 2, which is 4, times the one that was left in, and I get 4 square roots of 2. Okay, so for a while I'll write this out just until you guys get comfortable, and then eventually I'm going to switch over and I'm just going to do it this way instead of writing all that out every time. But I will for a while until you get comfortable. So my 16, I know that one off the top of my head is 4, but again, just to show you the technique, if I divide by primes, 2 goes into 16, 8, 2 into 8, 4, 2 into 4, 2. There's a bundle of 2, so I could rewrite 16 as 2 times 2 times 2 times 2. Bundle them, that's 2 squared, that's 2 squared. Split them, that's 2 squared times the square root of 2 squared, which is 2 times 2, which is 4. Shortcut, instead of writing all that out, there's a bundle of 2, which gives me the square root of 4, which is 2. There's a bundle of 2, that gives me the 4, which square root of 4 is 2. Nothing remains under, so my answer is 2 times 2, which is 4. Okay, 27, I can't divide by 2, so I check my next prime, which is 3. 27 divided by 3 is 9. By 3 again is 3. So I can rewrite 27 as 3 times 3 times 3. Bundle them, that's the square root of 3 squared times 3. Split them, that's the square root of 3 squared times the square root of 3. That cancels as 3 square roots of 3. Shortcut, there's a bundle of 3, that's 9. The square root of 9 is 3. He doesn't have a bundle, so outie innie is 3 square roots of 3. Alright, so let's try some of these. And again, you'll get better at these, and if you catch it, absolutely go for it. Alright, this one I know 100 is perfect. So that would be 100, square root of 100 times the square root of 5. That's 10 square roots of 5. Or, if you don't catch it, no biggie, I'm only going to divide by primes. And you can start with any prime you want, 2, 3, 5. If you start big, the only thing is I like to go in order because then everything lines up. If you go by 5 and then by 2 and then by 3, if you go out of order, it's not wrong, it's just not as easy to see your perfect squares. So by 5 would be 100, and I'm going to keep going with 5s until I can't anymore. 100 divided by 5 is 20. By 5 is 4. 5 isn't going to work anymore, but that's an even number, so I know 2 works, and that goes in there twice. So, bundle, that's 25. The square root of 25 is 5. That's 4. The square root of 4 is 2. And he don't have a pair, so he has to stay in. So there's my 10. And there's my square root of 5. Alright, on this one, I can't take the square root of 6 or 3. Not perfectly, so I'm going to multiply them together first, and that's going to be the square root of 18x squared. Because if you multiply 6x times 3x, you get 18x squared. This can be thought of as the square root of 18 times the square root of x squared. Well, for 18, if I break 18 down, by 2 is 9, by 3 is 3. Bundle, that's 9. The square root of 9 is 3. He doesn't have a pair, he's back in. So this turns into 3 square roots of 2. My x squared, those cancel, and I get the absolute value of x. Because again, when these are both even, you need the absolute value signs. So now I have, if you put the outies together, I have 3 times the absolute value of x times the square root of 2. Alright, so if we look at these, this can be thought of as the square root of 224 times the square root of x to the 6th. My 224, if I break it down, it's even, so I'm going to start with 2, goes 1, 1, 2, still even. By 2 goes 56, still even. By 2 goes 28, still even. By 2 goes 14, still even. By 2 goes 17. And you can see how I don't want to keep writing all this out all the time. I don't want to rewrite 224 as 2 times 2 times 2, you know what I mean? It gets monotonous. So hopefully we're comfortable enough to kind of switch over to the shortcut way. There's a perfect square, because 2 times 2 is 4, and the square root of 4 is 2. There's a perfect square, because 2 times 2 is 4, the square root of 4 is 2. He doesn't have a pair, so he's back in. He doesn't have a pair, so he's back in. So my outies are 2 times 2, which is 4, and my innies are 2 times 7, which is the square root of 14. Now if I do my variable, you have a couple of ways, and I'm going to show you the long way, and then I'm going to show you the short way. Okay, the square root of x to the 6th, that would be x times x times x times x times x times x. Bundle them, that's x squared times x squared times x squared, because I'm looking for bundles of 2. That is the square root of x squared times the square root of x squared times the square root of x squared. That's x, that's x, that's x, which is x cubed. So I have altogether then 4x cubed square roots of 14. That's my answer. Now, let me show you how to do this much simpler, because even this gets monotonous. When you have variables, or when you have exponents, okay, when I look at the square root of x to the 6th, what you can do is this, we'll learn it here in a minute, converting, but this is the same thing as x to the 6 divided by 2. Alright, we'll learn that here in a little bit, but what you do is you take this, that becomes your base, this stays the exponent, so that's on top, and this is on bottom. And then 6 divided by 2 is 3, and there's my x cubed. Alright, so for b, let's look at the square root of 250x to the 9th. That can be thought of as the square root of 250 times the square root of x to the 9th. If I break down 250, and I always start with my 2's, so that's going to be 1, 2, 5. Then by 5 is going to be 25. By 5 is going to be 5 again. So if I look for perfect squares, 2 of the same number make a perfect square. So there's 2 5's, which is 25, and the square root of 25 is 5. He doesn't have a pair, so he's back in. He doesn't have a pair, so he's back in. So this becomes 5 square roots of 10. Now, my little trick here, the square root of x to the 9th would be x to the 9 over 2. Well, darn. Last time it came out nice and pretty. 2 went into 6 evenly. I got 3. 2 does not go into 9 evenly. So what's that going to do? Again, I'm going to show you long ways, and then I'll show you short ways. X to the 9th would be the square root of 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. Bundle. I get the square root of x squared times x squared times x squared times x squared times x. This is split them now. This would be x, this would be x, this would be x, this would be x, and this guy has to stay back in because he doesn't have enough power to get out. So I get x to the 4th times the square root of x. Now let me show you the shortcut. You still can divide. 2 goes into 9 4 times. 4 times 2 is 8. 9 take away 8 is 1. So what you have is this base to the 4th gets out, and the base to this stays in. Out, in. So I have times x to the 4th times, the square root of x. So now if I put everything back together, my numbers and my letters, I'm going to get 5 times x to the 4th is my outie, and my innie is 10 times x, which is going to be 10x. Okay? Alright. Now, if we look at these, if I can multiply these together first if you want to, but that's going to be a huge number that I just have to turn around and break back down. So what I do is I say, well, this is the same thing as 192 times 54 times x to the 7th. So what I'm going to do is I'm going to break down 192 by 2 is 96, by 2 is 48, by 2 is 24, by 2 is 12, by 2 is 6, by 2 is 3. If I break down 54, by 2 is 27. 2 isn't going to work anymore. You know what? Let me switch colors. 54, by 2 is 27, by 3 is 9, by 3 is 3. So altogether, 192 times 54 has all of these factors in it. Okay, and that was a lot simpler than multiplying 192 times 54, which is huge, and then breaking it down. You can break them down separately, and then there's all your factors. So now if I look for perfect squares, there's a bundle of 2. Square root of 4 is 2. Bundle, that's 4. Square root of 4 is 2. 2 2's make 4. Square root of 4 is 2. 2 3's makes 9. Square root of 9 is 3. 2 3's make 9. Square root of 9 is 3. The only thing is I've got this one little 2 that's going to have to be left inside. So my outies are 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72, and I've got a square root of 2 left. There's my numbers. Now I have to do x to the 7th, the square root of x to the 7th. Well, that is going to be x to the 7/2. So I say 2 goes into 7 3 whole times, minus 6 leaves 1. So I've got x cubed out, and I've got x to the first in. So now clean it up, put my outies together, my innies together, I get 72x cubed, square roots of 2x. Okay? Alright, I want to do b the same way. I don't want to multiply them together first because that's going to give me a really big number. So if I break down 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. If I break down 125, by 5 is 25, by 5 is 5. So there's all my factors, and I need to bundle. So 2 2's make 4, the square root of 4 is 2. Sorry about that. There's another bundle of 2, that's 4, square root of 4 is 2. That 2 doesn't have a partner, so he's going to have to go back in. 2 5's make 25, the square root of 25 is 5. He doesn't have a partner, so he goes back in. So I have 10 times the square root of 10. Dang it. I don't know why this thing keeps jumping. So I have 10 on the outside and I have 10 on the inside. Ugh. Stop it. Alright, so now I've got to do my letters. Well, I've got x cubed times x to the first. That's the square root of x to the fourth. Well, oh my goodness. Sorry guys, I do not know why this keeps jumping from slide to slide. I'm not hitting anything. Alright, so I've got x to the fourth, the square root of x to the fourth. Alright, if I take, that's going to be x to the 4 over 2. And if I divide 4 by 2, that gives me x squared, so there's nothing left in. Oh my gosh. So that's times x squared, which gives me 10x squared times the square root of 10. Oh my gosh. And that would be my answer. Oh my god. Alright, try this one. Apparently it wants you on the slide. Bad. Hit pause. Come back when you're ready. And hopefully you got 5 square roots of 13. Alright, so if I break down 325, it's not even, so I can't use 2. I don't know about 3, but I know it ends in a 5, so 5 will work. That's going to go 6, take away 65. By 5 again is 13. 2 of them make 25. Square root of 25 is 5. He doesn't have a pair. He's back in, so it's 5 square roots of 13. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 2. Alright, so this is the same as the square root of 180 times the square root of x squared. So if I break down 180, by 2 is 90, by 2 is 45. 2 isn't going to work anymore, but 5 will work, is 9. 5 won't work anymore, but 3 will work. By 3 is 3. So I have 2 2's is 4, square root of 4 is 2. 2 3's is 9, square root of 9 is 3. 5 doesn't have a partner, so he stays in. So I have 3 times 2 is 6 times the square root of 5. Then I have to do my x squared. These cancel, but since they're even, that's the absolute value of x. Put it in order, and I get 6 absolute values of x, square roots of 5. Okay, try this one, hit pause, come back when you're ready. And hopefully you got 1. Alright, I am going to multiply these together. I mean, you can and you can't, it doesn't matter. That's going to be the square root of 12x cubed, which I can write as the square root of 12 times the square root of x cubed. Break down 12 by 2 is 6, by 2 is 3. 2 2's make 4, the square root of 4 is 2. 3 doesn't have a pair, so this is 2 times the square root of 3. The square root of x cubed is x to the 3 divided by 2. 3 divided by 2 goes 1 whole time. Take away 2, leaves 1 left over. So I have x to the first that's out and x to the first that stays in. So now clean it up. Oh, and this one, because this was even, is going to come out absolute value. Alright, so I have 2 times the absolute value of x times the square root of 3x. Alright, the quotient rule for square roots is similar to the product rule. You can either divide first and then root, or you can split them and do the top and the bottom separately and then divide when you're done with that, if you can. Okay, so on the first one, I don't want to divide, 9 doesn't go into 100 evenly. So when you can't divide evenly, you're going to get a decimal. That's a clue to split them. So this would be the square root of 100 divided by the square root of 9. Well, on top, the square root of 100 is 10, and on bottom, the square root of 9 is 3. So my answer is 10/3. Now on B, I can't, the square root of 48x cubed is not perfect, and the bottom is not perfect. So I'm going to use this rule that says I'm allowed to divide first and then root. So this would be 6 goes into 48 8 times. X cubed divided by x to the first is x squared. So now I have the square root of 8 times the square root of x squared. If I break down 8, by 2 is 4, by 2 is 2. That's a 4. Square root of 4 is 2. He has to stay back in. So this is 2 square roots of 2. This cancels, but it's going to be the absolute value of x, so my answer is going to be 2 absolute value of x times the square root of 2. Okay? Alright, you try this one, hit pause, come back when you're ready. And hope we got 3/4. Okay, I noticed that the top and the bottom are perfect, so I can say that's the square root of 9 divided by the square root of 16. That's 3, and that's 4. Okay, try this one, hit pause, come back when you're ready. And hopefully you got 2. Alright, these are not perfect on top and bottom, so I'm going to use the ability to divide first. 56 divided by 2 is 28. X to the fourth divided by x to the first is x cubed. That's going to be the square root of 28 times the square root of x cubed. Break down 28. By 2 is 14. By 2 is 7. That's a 4. Square root of 4 is 2. He stays in. So this becomes 2 square roots of 7. My x cubed is going to be x to the 3 divided by 2. 3 divided by 2 goes 1 whole time with 1 left over. So x to the first is out and x to the first is in. And this one needs bars because my index is even. So I have 2 absolute value x, square root, put your innings back together and you get 7x. Alright, try this one, hit pause, come back when you're ready. And hopefully you got square root of 83 over 4. The time in seconds that it takes an object to fall a distance d in feet is given by the algebraic expression, the square root of d over 16. Find how long it will take a ball dropped from the top of a building 83 feet tall hit the ground. Write the answer in simplified radical form. D stands for distance, and they're giving you the distance, so they're telling you to change D to 83. 16 does not go into 83 evenly, so I'm going to split it and do the square root of 83 over the square root of 16. The bottom, I know off the top of my head, is 4. 83, I can try and break it down, but nothing goes into it. 3 doesn't, 2 doesn't, 5 doesn't, 7 doesn't, which means it probably can't be broken down. So my answer is the square root of 83 over 4 seconds. Alright, so how do you let's go back to this one. How do you simplify a radical expression? You find the perfect squares and pull those out, and then everything else stays in. How do you multiply radical expressions? You can either multiply then root, or you can root then multiply. Same with divide. You can divide and then root, or you can root and then divide. If n is odd, the nth root of a to the n is just a, no bars. If n is even, then it's the absolute value of a. Alright, so we are at homework. Happy homeworking. And I will see you next time.